We are using a microphone today. Woo! So hopefully you can hear every little suggestion and tips and tricks. For those of you who don't remember, I am Becca Hudak. I work with the Woods Hole and the R2R project, and I've been a cat herder for the last few years in all these best practice groups. So this first session is about CTD. This is a long list of people that have helped in the last 30 years and have put some recommendations, have done some editing, have been on the email list to be updated. That being said, if you want to be part of the working group, even if you're just a listener, you don't have to do it. I mean, we'd like you to participate and contribute, but if you just want to listen and kind of get updates on what our recommendations are, you're more than welcome to be on an email list. So I figured it might be helpful to go over a general best practice. This is a little bit of review from last year. But for those of you who are new this year, it might be good to review. So naming conventions on your CTD cast names is super important. It's helpful to have your cruise ID in there. You can do by station number, you can do by CTD number, anything along those lines, no special characters. Please, please, please. It breaks our code, it breaks the code at NCI. And it's just a headache to deal with. CTD data structure, you'll have a raw directory, proc directory for process data, and a doc directory. It usually has all your calibration files for the sensors on that particular cruise. As an R2R event logger owner, I recommend putting event logs. Suggested ones are deploy, max depth, recover, abort, calibration, swapping sensors, anything along those lines. If you clean a sensor, again, it's nice to be able to log it. In the past, we've been able to see significant data improvement once you clean a sensor, and you can see it in the data. So if you look back like, why is my sensor all of a sudden great data now? We cleaned it, and this is what we found. Or there was a wire that was leaking, had water contamination. Things like that, very helpful when you look back at the data. This is some recommended cleaning recommendations that we pulled from Seabird, but also had them review all of our suggested practices. For those who are used to Triton X, the newer version is Turgital. Triton X is no longer available internationally for standards. So Turgital is the new one, or you can use white vinegar or bleach for very extreme cases of biofouling. I do want to preface, if you have any questions or interludes, this is supposed to be more of a discussion, a working group. I don't want to speak at you this entire hour. So to preface that, then this is open to discussion. What kind of bottles does your vessel use? These are some examples. General Niskin versus Bolster style right here. The big difference is the O-ring being inside the housing versus outside the housing. And then do you use different sized bottles, and how does that affect your CTD deployment? So I'm opening this up to the group. Does anyone want to raise their hand and say something that they use that's specific? Yeah.
You doing mics or no mic?
Mike's for the audience. Yeah.
I noticed in your pictures, you got internal spring.
Mhm.
Do you have any external spring ones? Or which one do you guys prefer? Because I was just curious.
We don't have a specific recommendation, but we're willing to hear what people have experienced, and maybe we can then incorporate that into our best practice.
Yeah, we use the external spring, like the side loaded kind at Amari, and they actually did studies at Amari with, just like putting a piece of tie gun tubing and silicone inside.
Mhm.
And it like measurably changes what's going on inside of the bottle from just the plastic, anything at all being inside of the bottle.
Mhm.
From just having like, even a silicone band in there is like giving off phthalates and stuff that actually show up when you do water analysis.
Mhm.
So we don't use anything inside of the bottles now. It's, we do like acid washes on the inside too, or water samples.
This is kind of a related question. Pros and cons of external versus internal tension.
The external ones are a huge pain to get on and off the CTD and adjust. But also, you get super clean samples if you're doing something like eDNA or you're doing like microplastics analysis, because that's the big thing, is like the microplastic stuff. That's, yeah.
Well, that's a good question. How often does this community see like that kind of testing, eDNA versus like oxygen versus like what do you guys see more often these days?
So on my ship, the Bigelow, the Noah ship Bigelow, we just about 4 times a year we do ecosystem monitoring cruise. eDNA is not included every time, but there is DIC, nutrients, but they are trying to move towards eDNA being included on our other projects as well.
For those samples, do you do a specific setup of your CTD?
There's there definitely is, Woods Hole, well, any FSC at Woods Hole will bring out their own larger rosette, their own CTD setup with fluorometer, par sensor, specific sensors tailored to what they're looking for. Because we'll stop in the water column looking for chlorophyll max and mid, bottom, surface, 10 meters, as well as like oxygen sampling too.
As a technician, does that affect your workload?
Not usually, there are times it does, I have sailed on a cruise where I did the DIC sampling and the barometry sampling myself. On this particular cruise, they like to bring their own scientists for that. But there are times where I've assisted them because they've been down manning wise.
Any other comments on internal, external tension or bottle types? Okay, you will move on. I can take that.
I mean, does it tend to be the scientist who chooses whether they want internal or external, or do you have both? No. Oh, really? You have one guy. Okay, good.
I mean, that's a good question, Allison. How many of you talk about CTD prep in your pre-cruise planning? Yeah, it's pretty. Well, like, do you just say check a box for CTD, or do you say I need this very specific stuff?
So we're working on it in MFP, we're streamlining it. Sure.
So I can't say this is what we always do because we're working on streamlining it right now, but we have the checkbox in MFP. But then what we're doing is in our cruise planning meeting, actually asking which sensors are mission critical and which are nice to have, and are you bringing anything additional, that kind of thing. So that, I mean, if something needs repaired, and if somebody shows up and they're like, oh, it turns out we can't do our science if you don't have this sensor, and you never mentioned it to us, it matters.
I've also seen questions just because I deal in the feed with, they ask the PI what type of O-rings they look at. So O-rings, they might not have different types of bottles, but they might use different O-rings depending on the sample.
Do they bring their own O-rings, or do they expect you to have them?
I think they expect us to, it probably depends, it varies.
As long as you talk about it though, right?
Yeah.
It's another thing you need to talk
So
about.
I know when, for the US Go Ship program, we bring our own O-rings.
There you go.
And we bring our own rosette for that matter, and bottles. But, and I don't, maybe the scripts text can talk about what normally happens during a pre-cruise on our ships. But they believe that the rosettes and bottles that are used on the script ships are similar to what we take out on the US Ghost Ship program.
Right.
We don't, when we ODF sales on the Thompson, we bring our own rosette, we bring our own O-rings, we change them out. So I think there is a standard and it is asked about at least O-rings during pre-cruise meetings. I think internal versus external closing, springs on the Niskins isn't possible. I mean, we have what we have. We can tell them what we have. If they want something that's external, then they would be supplying Niskin bottles.
Which leads us into our next part very well. So currently, on our CTD best practice document, we have a tier structure. So tier 1 is technically like a small vessel, no technician, specifically for CTD, and it's not the primary science objective. But include that the MarTech has to clean the sensors and store them. And they might conduct at least one validation method for each sensor. Step up from that is a tier 2. You have more than one technician. The science party has a little more responsibility. They might help deploy the CTD on the deck. MarTechs usually will train the science party on deployment, recovery, and sensor flushing. And then Ghost Ship would be like tier 3. That's your CTD is one of your main science objectives. The science party has major responsibility. They are cleaning, they're helping prep the bottles, they are collecting water samples. They might be doing oxygen testing on the ship. And in that sense, MarTechs are more responsible for helping train CTD watchstands, deploying the CTDs. Depending on the ship, they also might be doing the winch in the CTD. So one of the big questions that we had is this tier system still relevant to this community? Is this helpful and a best practice? Like if you are a tier 1 ship, these are your responsibilities. And then move on tier 2, these are your responsibilities. And it's kind of like a checklist. Is that useful for this community, or should it be more of a generalized best practice?
So would that be per ship or per science crew? Tier 1 and
Per science cruise.
Right. So the Rebel could have one cruise that's tier 3 and the next one tier 2.
That's correct, yeah.
Did you guys check the audio and whatnot to the stream? What do you think? They're not hearing it.
Oh, yeah, I've got that. Sorry, we're working on that.
Okay.
There was a bit of a mix up.
All right.
Thank you.
Do you
I
want me to
appreciate you looking.
pause?
No, you're good. I'm
Okay.
just gonna move them over.
Thank you. Any other comments? Or you really don't care? You just
I
want
want
best
it.
practice?
Okay. I want it.
I can project, for answer, like, my comment would be that I've observed a lot of variation, not just between ships and not even just between projects, but projects studying the same parameter, eDNA, for example, are not all asking for the same thing. So it might be worthwhile to list it in terms of the types of things that we should be, the types of considerations we should be making, and then figure out where the role of responsibility is for that one. Because we have project instructions that get recycled year after year after year, and they might add a new parameter, but not even remember to think about O-rings or metal springs versus tubing. So if we remember to bring that up when we're talking with the command or the science party, that might trigger something in their memory as well.
Would this be more helpful as like a checklist? You know, yeah, okay.
Does everyone else have that too, or am I out in the field?
We use eDNA all the time, so having a checklist of like what, I guess what would be a contaminant for that would be helpful.
Any other comments? So I don't have to run back and forth. So this is kind of on the same line, like, we really want to make sure our best practice document is going to benefit you as a community. So that being said, do you just want a all-inclusive manual that could be 100 pages long that you have to search through? Or would you rather have something that's, just the basics, a couple checklists? And if you need a redirection to some more information? Is this something that you're gonna be printing? There's some appendix options that we're thinking about being able to be printable, put it next to your computer station as a checklist. What is gonna be good for this community? What are you guys looking for?
No pressure. Having as much information as possible, but also having it, I don't know, the way you have it laid out, like checklist style, like having something that you can post by the science computer, just like general reminders, I think would be helpful, and then also reference to a more deeper detailed document.
That brings up another question I have. Is this something that you guys, expect to use that you can search on your computer so you can like search for things? Or is it something you're gonna print out because you don't have internet connection or you're 9 north or something like that?
Okay. I think like having a document that you can reference and then having pieces of that document that are printable PDFs, like with checklists built into it. So like kind of combining both aspects, but
They want it all.
we want it all.
In my mind, I'm envisioning something that you can print off, laminate, very nice checklist. Okay.
Would the visa be?
So this is more questions, these that like what do you guys do? There's a lot of contention about turning deck units on the deck, in the air, in the water. I'm curious what you guys are doing currently. There has been some changes with the large system that it's not as dangerous to turn it on. But I'm curious what you guys see as a community and what you guys feel safe doing.
I'm so sorry. Okay. So we actually had somebody get shocked this year.
Really?
Yeah, so we turn it on when it's in the air and then start acquisition right as it's turned on. So like right as it's like usually frame right on the surface of the water is when the deck unit's turned on, when we know that any possible hands are off of the unit. We kind of had to get strict about it.
Do you have a large system?
No.
Or
No.
no, okay.
So. I'm a chemist, correct me if I'm wrong, but if somebody's getting shocked, I would want. Is there something wrong? Why was that person getting shocked? Was there something wrong with the system? That
We had open like wiring,
is that common?
exposed wire.
Yeah, I know, but you don't want open wiring, so anyway,
Well, you don't want it, but it can happen.
okay. This is good, I mean, we always, for the cruises that we do, ODF, Gosha cruises, we have this discussion, and there's usually a compromise reached, because having an on-deck pressure reading before the CTD is lifted off the deck, and it goes in the water, and on-deck pressure reading at the end of the cast is critical for the CTD processing to do. Normally what the compromise is we turn the deck unit on after all the slack is taken out, so hands are off. And I understand why preferences for this community is to not turn on the deck unit or the CTD until it's in the air or in the water, but for science deployments, and Aaron can correct me if this is no longer an important piece of our processing, but historically having the on-deck pressure offsets before and after the cast is, as part of the continuous CTD cast, is part of what we need.
I'm on the Lasker, and every year we do Cal Coffee, and historically, like Jim Wilkinson,
Yeah.
that group. They wanted the deck unit turned on deck to get the pressure reading. But now that they've all kind of retired and gone away, they've changed it and they no longer do it. So all of our projects are when it's in the water. Turning on the deck unit when it's in the water.
Cal Coffee was originally, I mean, historically, they were our group and then split off. I mean, that's before my time even, so I understand where that came from. But for the ghost ship stuff we do, Aaron nodded at me that we still want and need that on deck pressure reading.
But is that part of the tiered structure, for instance? I mean, if you have the marine tech on deck launching and the deck units are in the lab, the back and forth running is, it slows the whole thing down. I know that if somebody wants it on the deck, we would do it, but it would be different than our standard procedure just to get things done in a timely manner when most of the other scientists aren't processing it the way GOSHA does. You know what I mean?
Yeah, no, I understand. I'm just saying there will be those special cases when the GOSHA community wants that reading, and usually there is somebody at the winch and there's communication between the deck and whoever's sitting at the CT.
So is it something that we could do, like, okay, we're gonna turn on the unit on the deck, get the pressure reading, and then turn it off, deploy it, or does it need to be
It
aligned?
needs to be part of the continuous data stream.
Thank you.
For us, this is special case, like not all cruisers are gonna be like that, and we always have this discussion and usually reach the compromise where it's turned on after all the hands are off. It's on the Rebel, we have the LAR system, so nobody has to touch it after that. On the Thompson, they don't have the LAR system, so it's people are still gonna be handling that, but they shouldn't have to touch the rosette or the wire after that, because they take the slack out, turn the CTD on, and there are taglines on it, but no one's actually touching the frame or the wire at that point.
Yeah, in that case, it's just running back and forth to the lab, but if it was a case where someone wanted it, we would do it. It's just not gonna be part of our
Standard.
daily standard, yeah.
Yeah.
Do you want to do like a show of hands, like how many people do it?
Sure.
While it's on the deck?
Okay, show of hands, who turns on the deck unit on the deck?
In standard operating.
In standard operating procedures, yeah. What about in the air above the water? Once it touches the water?
Somewhere in that range.
It's lowering down.
After a 10-minute soak and then comes back to the surface? Which brings my next question, soaking. How long do people soak their CTDs? Do you still soak your CTDs?
2 minutes, 3 minutes.
We vary how long we soak our CTD, because we have projects that are kind of time sensitive. And so we will do the minimum soak of just about a minute, for that project. But then we get to projects where it's all about CTDs and we'll soak for 5 minutes. Not necessarily like we have to, but that's just where we're doing all of our planning for the actual event. So we'll just end up sitting there for quite a while. And then we have projects where it's kind of in between and we only soak for about 2 minutes.
Our scientists have a 3-minute timer that they use for every single project.
At least I can.
Along with that, is that something that comes up in pre-cruise planning, like we will spend this amount of time, or is it changed depending on how much time is left in the cruise and weather?
Our ship has 120 days out of the year dedicated to a specific project, so it's just standard for that project. But the other projects, it is definitely something that gets communicated to the survey techs beforehand. And then like our winch operators, our deckhands, our bridge are all just under the guise of, we just wait until whatever comes across the radio.
That's all up for you, Erin. I would say in terms of soaking, I've experienced science groups that have differing opinions amongst themselves. What they wish to soak the CTD for, so. Even if you talked about it in the pre-cruise meeting, that might not necessarily be what you end up doing.
I guess another thing to add is kind of regardless of what tier you are, the official, or not the official, but as of 2014, Seabird's stance is that the deck unit should be on 5 to 10 minutes before getting on station. You'll notice when you start or when you do your soak that it will drift positively or negatively, and that your level where you are, but it's just the sensor warming up. Which is a benefit of turning it on deck, because then you also have your barometric pressure standards that you can compare it to. If you're gonna do the Seabird recommended SB9 calibration routine, then you need to do those on deck tests, which you can do before getting on station, just not having anyone touch the wire. But you can also do it cast by cast if you turn it on before getting on station, and then just lift it up and pour it over. So that's another thing to consider with your soak times is if you do for a minute, consider turning it on before putting it in the water. Then you'll get as many minutes out as you can, and it will be as good as possible when you're going to lift it up and lower it down.
So, I'm also wondering, we're talking about 10 meters. Is everyone pretty strict about the 10 meters? And then also after when you're on your way up and we're stopping before we fire the bottles, how long do we wait? Some scientists just say fire away, and some say I've got to wait 2 minutes. And then we remind them that there's 12 bottles and that's going to add 24 minutes or 24. Then I'm just wondering what people do for when right before they fire the bottles.
I have the same question for everyone. It depends on our group. So, and it's kind of changed in time with each group. I try to make it so that we're actually sitting there to let the water, settle out and stuff. Seabird, I think, recommends like 10 minutes at each depth, which is not gonna happen. But I've had like on Cal Coffee, for example, they used to let it sit for a minute or two and then fire a bottle, but now we have newer people that are coming on and they're like firing right before like we even stop. And I have to tell them like, hey, slow down. So it's different, yeah.
So for us, the oceanography branch has told me a strict 60-second wait before we fire. She has also said that, of course, anything past 60 seconds is okay as well. But she said to wait 60 seconds at every depth, and then if we are firing multiple bottles at that depth, she said minimum just wait until that light that pops up when you're firing a bottle turns off, and then you can fire the next one.
Are you firing from your deck box?
No, the fire command on C-Safe.
I usually just take my sweet time filling out the cash sheet and they fire. Not very scientific. So it's definitely a minute.
Within the Gosha community, we don't agree on how long an ideal stop is. We generally do agree that firing immediately after you stop or slowing down and firing is the worst thing you can do. It's better if seas are rough and you want to get that CTD out quickly, for our perspective, it's better just to trip them on the fly without slowing down. That's the second best. And then the best is to stop for a debatable period of time to let the water settle out, so you actually are, sampling. And there's papers. I think our general rule is 45 seconds. But within the Goshen community, that's still debatable. There's people in Europe that want to stop for 2 minutes, and we're like, that's too much time over the course of our cruise. So.
And that's about the same thing what we do. We wait about an hour, sorry. That was a good one. We wait about the 60 seconds, and if the fire several bodies the same depth, we wait until the light on the deck unit out for the fire. However, we did have oceanography groups on boards, who actually were only interested in bottom water, right, the biggest depth, and then everything else was on the fly as we say. So we just come up and we run it that way. On fiber 2, we do have the additional issue that we're running off the side as soon as the ship starts rolling. You're sometimes 2 or 3 meters going up or down anyway, so hitting that exact right depth that they want is going to be extremely difficult, and you have sometimes no chance other than to fire.
Yeah.
Any other strong opinions? Next question for the group is, if you'd have it, what kind of ship processing do you use or have available for the science community? It could just be Seabird software, that's fine. Anything different than Seabird software?
On our ship, we use, for most of our projects, a software called Oasis. And just process with that, and then it real time sends all the casts on shore, so that way she can immediately start processing all of the data.
We use a MATLAB script that does about 12 different things instantly. It just runs it through the SB data processing. That's pretty nice because it does like 12 processing steps that you have to manually do in about 30 seconds. It's nice.
How about a raise of hands who does not use Seabird software for processing on the ship? Oh, okay, you're already there. You count, but not this. It says.
We are.
Okay, so I had sent an email out to the group, whether you read it or not. And we wanted to see like what your experiences are with the CTs. Have you had anything severely malfunction or any tips and tricks that you'd like to share that we can include?
It may just be new to me, probably not new to anyone else, but troubleshooting a cable that had gone out. I don't know what happened to the cable specifically, but trying to figure out what the problem was, because I had 2 fluorometers that I had put on the CTD, and the first cast that had gone on, it went well, came out of the water. The next cast, nothing on the CTD would work. And at first it looked like a blown fuse, so I checked all the fuses, but they worked. I changed the deck unit and it worked on deck. And so then I just started swapping the fluorometers, swapping the cables, and when I got to that last cable, it wouldn't work. And I had seen it once before with an oxygen cable as well, and that one actually blew our fuses. Suddenly we were at 1,000,000 meters of depth, and we found one of the fuses had gone, and when we replaced it, it then blew the power fuse. So then we just had to swap the unit altogether, as well as losing communication at depth around 100 meters. And it was incredibly tough to troubleshoot because it worked above the water. It didn't work in the water at that depth. And, cruise constraints did not let us do every troubleshooting step there was, but.
Anyone else do the homework? And
On the Dyson, when you running oxygen sensors in a pair, it's best thing to connect them with a tube that has water in it. So they don't. So the baseline doesn't crawl away. I wonder what other people do.
anyone have an answer to that?
Well, didn't you just do the O2 best practices, or that was processing? Didn't we just hear about the about
That was Aaron,
processing?
processing
Okay.
after
Was
the
it
fact.
measuring it? 'Cause
I
ODF
mean, one of our recommendations in your basic CTD package is to have dual temperature and salinity sensors. That setup is, we're still trying, I guess we're figuring it out. There's vertical, horizontal setups, lots of debate there. CTD is a fun one because there's lots of, oh, we do it this way, we can do it this way, science wants to do it a different way. So yeah, it's definitely something we're trying to nail down. It's one of the reasons why this best practice is taking a good chunk of time. Did I have another question? That was not on here.
So, in January, we had our Cal Coffee cruise. That was probably the worst one that we've ever had. There was a lot of different issues. Switching out deck units. I actually sent a 22-page document to the RV Tech mailing list showing everyone like what happened. But we switched out deck units, fuses. We went through like 10 fuses. We did mega tests and continuity tests through, the 9+ end through up to the slip ring. And then we have a junction box that goes to the lab. And we have like a key switch that goes from like hydrographic winch 1 to 2. The combination of things, our slip ring was bad. Also, there was no, the wire from the back of the key to the junction box was not shielded properly. So there was just, we fried like 2 9s. It was bad. It was really, really bad. Two 32s. We got scorch marks in the same exact spot in our SB 32s. So yeah, it was a very fun January.
We just set up a 9 that we received from Seabird and had lots of issues with pumps pumps initially turned on, pumps stopped turning on. We were not getting any voltage from those bulkhead connectors. We had lots of conversations with Seabird about this issue. Apparently they're having a problem with the pump controls malfunctioning. So if anyone else experiences that issue, you may need to send your unit into Seabird, which is not fun.
I remembered my additional question. Would it be helpful to have more information on physical wire terminations and how to make it out what values to be looking for? Or is that something that?
Yeah.
Okay. Nods of yes.
That would be great.
A quick follow-up on that real quick. I had the same issue with my pump and the only solution was sending it and putting it into the manual and automatic. It was the only thing that they told me I could do. I did want to go back to the data processing and ask you guys this. When I first became a marine technician, it was explained to me that there's a fine line between, your expectations as a technician and then what the scientists are supposed to do once they get home. And I have had cruises where they've asked me to do just a basic processing and then a basic bin average, which I'm happy to do. But then I've also had cruises where they've given me this huge packet and they said, process please, I won't accept anything else. And I've had to be like, no. So I just wanted to know what you guys did with the rest of the fleet, what your limits are, because there's a point where human error starts to go in, and I want to give the scientists like the truest, best data, you know, and I don't want to accidentally ruin it. So what do you guys do with that?
We don't process data. And, if they want something that they're gonna write a paper about, if they want it done right, then they need to have people who care about water cone stuff to process the data. I can collect it, I can make sure the sensors are working, and I can keep the internet up at the same time. I cannot process your data.
Yeah, I was gonna say, I think that's pretty standard across the fleet. If there are people who have special needs, ODF comes on board, they process their own data, right? So if there's special needs or they they do it themselves, and I think pretty much everyone in the fleet doesn't. Well, this is, yeah, not really. How about that?
Don't let them tell you, but so and so does it for me. Doesn't matter. I don't care.
Yeah.
I guess I have kind of a specific question about processing, and maybe. Please don't tell Brandy that I do this. No, so when I'm doing a CTD cast and I need the sound velocity profile, I start the data at 10 meters, come up to the surface, go back down. When I try and process, I can't get it to start back up at the surface. So it always starts at 10 meters and goes down for the processing. So I want to basically start the cast at 10 meters, come up, and then have a data file that starts at the surface and goes down to the bottom.
So you're recording yourself.
Processing just the upcast.
Yeah, I've tried that. But does anyone else, someone down there? Yeah, I think I've tried that.
There was excitement down here. I have a specific answer, and what we do is we go down to 10 meters. We start what we call our X cast. So we name the file as we would, and we add an X. We turn the instrument on at 10 meters. We make sure everything is good. Then we stop recording, we go back to the surface, and then we start the real cast. And then that's your full clean column.
Okay.
Oh boy. I'll start over here.
Just curious, do you start archiving before you do the soak? I have never seen this before, but I also never archive before the soak.
Yeah, we start this, as soon as it's in the water, go down, we archive all that.
So we've always been told not to archive that, they just never wanted that data, so, we personally have never seen that happen.
But you
Yeah.
can delete lines, can't recreate lines. And so do you start recording to make sure you capture the whole thing? Or do we wait and risk missing you know what I mean? When
Yeah.
you have one person doing the whole thing, so, because you can delete lines out of the data and then process the rest of it.
Our science group, they don't want the soak in the data, so we just start acquiring right when we get into the water. And then once we're done with the soak, we go back up to the surface and then we start archiving for the downcast.
Okay, all right. Thank you.
Yeah.
I'd say it's like, there's so many different ways to be able to do it, to facilitate what each, I guess, person wants, but as far as a human error, thing, at least for what we do on the ship, is some people do start archive just below the surface when you're ready to do it. But you don't want on a ship to have two different people do it different ways, and so what we did is just start archiving. And you actually have the option to do a mark scan. And if you have a mark scan on the file, you hit that right when you're below surface. And during the processing of it, you know that mark scan. So it's like, for example, 2148. And then when you process it, you just make sure that that's where it starts the process. So mark scan, it's an option too. So,
I'm committing you, so.
This is just a question because we were doing work in the Gulf and some of your stations aren't like 10 meters of depth. So when would you start? When would you stop? What is like your control? Does anyone have an answer for that?
Anyone have a strong opinion?
So something that we do with the Go ship cruises, we tend to choose areas or parts of water that are stable for us to look at during our soak depth. So don't put it down on your thermocline, don't put it down anywhere like that. Where any sort of ship heave is gonna cause it to, you're gonna have lots of changes. You want your values to be pretty stable. And then, within CSAVE, put up a plot of your primary and your secondary. That's one of the reasons to have a primary and secondary plumbed line, is then you can look at, all right, how are my sensors doing relative to each other? Are they in agreement to within 1% or something like that? And if they aren't, then you've got something that's been sucked up or something isn't turned on the right way, and you immediately know like this soak was worth doing. Whereas like if you're looking at, I don't have 10 meters to work with, I think it's kind of just get it in the water and make sure that both of your lines are functioning the way that you're expecting them to function, and then you can go down to 7 meters or whatever you're doing and then come back up.
So on this trip, there were lots of stations that were really, really shallow. And we would actually do something called a CTD dangle, which I want to know if anyone else does that. So they were focused on like hypoxia and oxygen concentrations. So our winch operator would, do the full cast down the bottom. And then at the top, he would put the bottles out of the water, but keep the sensors right at the surface so that we get the skin of the sea temperature. For all of the sea parameters. I was wondering if anyone else does that.
Hello, sir.
Only the CTD partially.
I am. It's on the other computer.
Couple minutes? Yeah, maybe like a minute or two, and then that's whenever we would turn it off and then recover.
We kind of based it off of what the, the.
Yeah, it was more based on like when the waves were coming.
Recover. Yeah, I'm just curious now.
Yeah. Yeah, cause it's not like a toe-yo, you're literally like, no, leaving the rest of the cast at the top.
Yeah. It's also been a project that's going on since the 80s, so maybe that was like a standard back then. I wasn't alive. So.
Oh, if you just had brought up another good question, Toyos, does anybody do, because we've gotten rid of that on our boat. We've had too many accidents, like pulling up some weird cable out from the bottom of the Gulf of Mexico. We don't do them anymore. Does anybody do Toyos for like their big CDDs?
Yeah.
Any specific like safe practices you do to prevent accidents like that?
Multi-beam.
Oh, that's.
Anything more than multi-beam? Is there anything specific you look for to prevent accidents? Or you just let it go? Hope for the best?
And we are doing, oh, yeah. So there's a specific time in which we would do toyos, and that's only when we're searching for hydrothermal vents. And so that's mostly when we do it, like, and so like, obviously we want to map the area first before we do it. We don't want to hit a stack. And so there's all these things we have to account for before we actually say we're going to do toyo. And then we have certain operating loads to make sure that why is the tension going up when it shouldn't. And yeah, so there's a lot of things to think about, but yeah, we've never accidentally brought something up, but you know.
A related question, how many of you stop at 10 years above as ocean bottom or go below it?
It depends on the cast, and also the sea state. If, yeah, if it's a shallow cast and, and a rough sea state, we just keep it off 10, but normally just go 5.
Our scientists prefer 1 meter. And I have a lot of anxiety around it. Do you make them change that if it's a high sea state?
They will, yeah.
I just want to go back to the Toyo for just 1 second. Something to keep in mind when you're doing Toyos is that you're supposed to have for Appendix B, MCD documents for all of the operating configurations. So if your overboard handling system is supposed to have the path laid out for if you're doing Toyos, and something that pulls into consideration is the wire angle being aft. And so if your MCD doesn't cover wire angles being aft, your MCDs need to be updated and or used as an excuse not to do Toyos.
Same, 5 to 10 meters is the sea state. I've also had to do less than a meter because they attached a monocore to the bottom of the CTD. So that was very seeing it go like 5, 4, 3, 2, 1. And I was like, yeah, get some sediment samples.
Our ship, same standard, 5 to 10 meters, but I have been on a ship that isn't used to shallow CTDs, i.e. anything less than 500 meters. And they would not let me go within 50 meters of the bottom. And to which I tried to explain to them that I am comfortable doing that, and that is why I run sonars and all that. But they just wouldn't have it. And they were like, they will be happy with what they get. And I was disappointed.
Did you have another question about Toyos?
I was just curious of like, how long have people done Toyos? I think our longest one was like 32 hours.
Holy.
Yeah.
Anyone had an answer to, does anyone else do Toyos or have ever done Toyos in this room? Oh, would someone like to explain what a Toyo is exactly?
Yeah, go for it.
The Toyos we have done, we've used a new sonnet under a CCAT, basically going down to 10 meters, back up, and then back down to 10 meters and just keep going up and down like that for however long they decided they wanted to do it while we were looking for tuna larvae. And we've also done it with these bongo nets, plankton nets that were square framed, and we only went down once, back up, down one more time, back up, and that was it. Basically just going down to a depth and just back up and just repeatedly.
Paul, want to add one?
In retrospect, thinking about this, one thing we did end up doing, and I don't know if this is becoming best practice or not, but we have a beacon on our CTD. We visualized it inside of Flighter Mouse and we overlaid that with the multi-beam. So we knew where it was in position under the vehicle, how far it was and more. So that was part of our best practice for that.
And an altimeter.
As well as the altimeter, of course, right?
And then what we can actually do is get the beacon position as a GPS position for the CTD, so it's more accurate instead of just as a position, because it's like strung out so far away, because it's like 7,000 meters strung out or something like that, so.
To add to what the Falcor is doing, we have the beacon on it. This was with work with OceanX. And then looking in the multi-beam, but also the EK80, you can see it perfectly where it is relative to the ship and coming back up. and streaming your depth and so forth. And we would do our toyos for hydrothermal vents and then also bomb and that type stuff, so. Never 32 hours though.
So for this document for the standardization, wanted to bring up a consideration for different kind of environments. You know, you've got the colder climates that, you know, I personally never worked in, but you know, you have different things that you're supposed to do in those kind of climates. So you have brine pools that there's a lot more specifics you have to do for that. It'd just be great if that was also included in this kind of documentation that you're working on.
We can do that. I think we should also include a calibration, like what you guys do process for when you send out your stuff for calibration. Like, do you have multiple of sensors? Or is there like a different company rather than just Seabird that you send your equipment to? Or is there third-party companies that you have that's not just Seabird sensors? Yeah, I have questions about that.
I would also be interested if you do not go to Seabird specifically.
There are certain labs all over the world now that have a license from Seabird to calibrate. So if you're in Australia or around Australia, CSIRO is allowed to do that. In Europe, you've got TUM in Germany that have the license to do calibration on Seabird equipment. And they have the tank testing and everything else for the pressure testing. So it's not just that wherever you are in the world, you have to go the long way with an RMA to send it all the way to Seattle. So there are different other labs now around that have the capability. I think there's a list on the Seabird side. Otherwise, just contact Seabird and they're gonna tell you.
Does anyone calibrate in-house at their institution? Yeah.
So we don't, I don't personally do it, but I collect salt samples, so that way onshore, NEFC does connectivity cell calibration for us. And she also will typically calibrate the oxygen sensors for us as well.
I'm gonna move the slide because I can't remember what I have left. And we are getting to the end. Oh, if you have an institutional SOP that you would like to share, we are interested in potentially creating an index that can be shareable throughout the community. If you want to share your institution SOP, please give us your email and we will be in touch. I am gonna put a shameless plug. At R2R, we do, I am part of the group that does CTD, QA and BP. And part of that process, we created a CTD plotting routine, which is a fun name. It's our Mojolicious is the plugin. We have created a step-by-step guide on how to install it on your ship if you would like it for both Windows and Linux and Mac. And you can get it through the R2R GitHub. If you have any issues, you can contact us. But what's really cool about it is that it can do as many casts on top of each other as you want in different colors. And it's zoomable and you can hover over it and know which cast is the odd man out, which might have been needed to clean or has suspicious data. Yeah, it's out there for the community. It's open source. Yeah, shameless plug. This is a example of kind of a decision tree in a way, like how much time you have, like post deployment. If you have 30 minutes to dedicate 60 minutes or more, post cruise, just some suggestions on how to clean your sensors, clean your CTD between casts. I'm gonna leave this up here so you can really absorb it. I think we might have a couple minutes if anyone has any more questions for the group while we're all here in one room.
How many people want to sign up for this group now? Send your email to.
You'll take more working group members, please. Yeah. Question or was that a volunteer?
volunteering to be a part of the group. Okay, find me after and I'll get your email.
It's just kind of a quick question for you two. Previously, you were talking about wanting the CTD turned on deck so you can get a pressure reading. But my question is how could you mitigate risk by adding a barometer to the system and not turning it on until it's in the water? You have your barometer at the location where the CTD is, as long as you know the difference between the two devices. So. Well, another advantage that you have when you turn it on deck is you know kind of, is it at zero? Or is it reporting like kind of what we're expecting? And if you do a post-cast recovery of it, is it still reading zero? And if you deploy and it's zero and it comes back and it's reading -4, then there's some point during there where there's been a problem related to the CTD, or is that's kind of dancing around your question?
Yeah.
I get the feeling, okay.
Yeah.
Can you rephrase that for me?
If we, I think what he's trying to say, if we do a couple of casts where we have the barometric pressure reading as well as the on deck, then we know the difference between the on deck reading and what we're getting as barometric moving forward for the next 150 casts. Can we just use that the calibration with where we had the on deck pressure pre and post cast and the barometric pressure? So we're kind of like doing that calibration.
It's an extra step, but
Yeah.
it's safe in that sense, right? And that's what Seabird recommends you do. The final two coefficients that go into that XML con for the pressure sensor are your gain and your offset, which you calculate from what you read at the bottom versus what you know the pressure should be at the bottom based on your wire out, which is often hard to get. Or you have your pressure offset from a reliable source on deck. So that's when you turn it on before doing any of the stations, see what it's reading and do those interspersed, kind of like a light dark test on your transmissometer. And then recalibrate it or plug in different values to that last gain, offset value, is kind of what they recommend doing, but you also want to turn it on for a few minutes. That way it has time to level out and finish drifting. With ODF, we like to do it on a cast by cast basis because we don't assume that every cast is the same. We also realize that air pressure changes, and so your barometer may not be always telling you what you're expecting it to be giving you. And your CTD may be more consistent in some ways than your barometer is, but that's all kind of getting into the nitty gritty of what the IAPSO group is starting to look at, which is kind of asking questions of Seabird's routines and our routines and like, are we actually doing things the right way? And is there a safe, better way of doing it?
What are we on time?
Yeah.
Oh, okay, we are done. It is now break. Please. Please stay tuned for more best practices. Next one is EK 80.